what this is we've got this GitHub repo, it's a template, and we put this together as a way to both enable quick proof of concepts, because we're very frequently being asked, okay, I need to spin up stuff in all these different cloud regions to get the full value of testing. Can you help us do that? And then also we didn't want to do throwaway work. So, okay, how can we build kind of the starter kit that someone that is maybe not as familiar with DevOps and this new approach can take forward and continue to use kind of in perpetuity. So I'm not going to go through all this stuff here. There's prerequisites, right? There's, config workflows, detailed configs. This is actually what we're going to end up deploying today. So we're only leveraging 2 clouds here. We could leverage more if we needed to, but we're going to have these 2 regions in Azure. We're going to spin up a couple VMs, couple VNets, 2 regions in AWS, also going to spin up a couple VMs. We are also going to, hopefully, if we have time, take a look at how this access pattern will work. So, we're sitting here in California, and we're going to onboard like a little WordPress app, very simple little VM, Omni, straight off of the marketplace. And it's going to be set to cost optimized, and we'll hit it and we'll see, we should go directly to it, which, still better than VPN, because wherever my app runs, even cost optimized, I go straight to the app. And then we'll change a couple of things. We'll make it performance enhanced. We'll make it multi-cloud performance enhanced, and we'll take one of these other paths. And that all happens automatically from our sensor network feeding in the data. So the way this works is, a customer will start by editing this Prosimo config file. This file really just contains a handful of things. This will be configured in their Prosimo environment. So they'll take that, pass that in here. Edge CIDRs they'll define, IDP they'll define, regions where they want edges deployed. We've already deployed edges because the edge spin up does take anywhere between 20 and 40 minutes, depending on the cloud provider. So we will actually create the Terraform backend as well. So there's pipelines that do that. So again, really meant to simplify this. So quick question, any guesses as to which cloud provider spins up their Kubernetes instance the fastest?
Google.
Google. Who's number 2? I guess the second one is Azure is number 2.
Really?
Yeah, EKS is the slowest to spin up for whatever reason.
50-50.
Yeah, yep. Google is far and away, though, the fastest, pretty much every time.
So by region?
Do what? It does not really vary by region, no. Yeah.
So if a customer is doing this for the first time, are they accessing this? Where are they accessing the?
So this is GitHub. It's
they get it. They pull it from your GitHub.
Yep. Public repo, and it's a template. So they'll say use template, and then that'll just clone it into their environment, public or private. Private, really, if it's going to be long-term production, but for POC, public is fine, because we made it a point to make sure we're not storing any secrets, any keys. That's why we initially were like, do we want to provision the Terraform, back end? And then we were like, yeah, we kind of do, because we just want to make sure that stuff isn't getting stored in a public repo. We've also built a lot of custom unit tests and other things as part of this. So I'm going to go in and just show this really quickly. I'll just put in a wrong value here, and I'm just going to say propose change. So this is what someone would do. We also package all of this as a container. So, our Terraform provider, Terraform binary, all of that is being delivered and downloaded through this GitHub action as a container. I'm not going to issue a pull request yet. What's actually happening is this. So I made that change. It's triggering the pipeline run. Again, very simple for someone that's never done this before. We have all these automated triggers that are set up, so you don't even really have to know what you're doing. We're doing some linting now. Again, for people that aren't familiar with linting, it's just making sure that the code is written in a nice, clean way, the syntax is correct, and then some custom unit tests where we are looking for things like, the IP that you put in is a valid IP. Is it a valid cloud region? Does that cloud region actually exist, right? Are you available to deploy there? We're going to be expanding on these unit tests to check things like, is there quota, right? Do you have enough capacity in that region to deploy that before we do the deployment? We're looking at edge, right? So do we have a Prosimo edge running, in that environment where you're trying to deploy? Now, if you didn't, we would by default just create that edge, but that may not be the behavior you want, right? Because it does take 20, 30 minutes to spin up an edge. So we want to check for that ahead of time to make sure that was indeed the intent. So I'm going to go here and look. As I said, we've got these unit tests, and here we're seeing the error.
You have a consistent backend network, like the management layer network. So you have reserved sets of IP ranges that you always use for your core, and then it will.
For our clusters, yes. Yeah. So when we spin up, one of our Kubernetes clusters and edge in any cloud region, yes, we have a set of ranges that we use consistently. Yeah. And we're using like the KubeNet or, so we're natting kind of all the inbound addresses. Yeah.
You talked about measuring for quotas because this is one problem with Terraform. Terraform just doesn't care. It will just like blindly try and push it out. And also, I'm going to dig in because I noticed you have no wait state. Terraform with cloud, unfortunately, is not generally smart enough to actually really wait around. Like it's just like fixed. I'm going to wait 10 minutes. And if at 10 minutes, 1 second it goes, too late.
Yeah, exactly.
How do you manage those kind of cloud idiosyncrasies or Terraform idiosyncrasies, actually, that based on how it interacts with the cloud?
Yeah, so there's not much we can do there, right? Because if we're leveraging Terraform to deploy, we're stuck with all the idiosyncrasies that come with using Terraform to deploy, right? So nothing we can do there. Now, we have in our deployment, there is a setting that we have called wait, and I have it disabled because sometimes it takes longer to do certain things because, again, we're waiting on the CSP to respond. We're waiting for that API call back. And where you're doing something like this, where you're using hosted runners, where you pay by the minute for usage, you get 2,000 minutes free. But beyond that, right, you're paying. So we want to make sure that we're maximizing we're not just sitting there spinning, waiting for nothing, right? So when the API call is sent for us, we're saying that's good. And if it fails, rerun it or, figure it out. Now, again, we can't do that with all the infrastructure outside of what we control, but for ours, we do have that wait statement in there. So now I'm seeing this region check. Hey, this is not allowed because it's not valid for cloud, AWS, and region US East 2. Allowed range is this. So I'm just going to go quickly back in and fix that. So that was here. And we have a lot of documentation here, more to do, right? Because again, we want to make sure that we're highlighting everything that's happening, that someone knows what to do when there's an error or how to fix something.
That error message is very nice to see, considering there are some error messages that said feature failed, we'll try again.
Yeah, we're trying to put as much, and because my background, again, I came from infrastructure. I was in internal IT for 15 years, and I went to NetApp, then I went to Pure Storage, and I went to Microsoft. And the Microsoft move was like, I'm learning everything new for the first time because it was all agile, all DevOps. And it was hard for me to pick up. It really was. I mean, it took a long time for me to kind of fully understand it. And I just know the pain that I had. So I'm trying to make sure that others don't have that same pain as they're going through this. So it's going to run again because I made that change. I'm going to just go ahead and assume that it's going to work. So the next process would be, okay, if we have passed all of these tests, I can create a pull request. Now this pull request is going to be the process of taking what we just did, moving it out of that test branch, right, and then deploying it into production. So that's triggering another pipeline as soon as that happens. So here it goes. Oh, sorry, it did not trigger. It's still running the other test. And because we're short on time, I'm going to manually kick it off, which we can do. So we do have within here the ability to trigger these pipelines on demand. So I'll just say, just run it. And off it's going to go. So while that's happening, I'll do a couple other things. So because we are building not just our infrastructure at this point, we're actually building some of the cloud infrastructure because we had nothing, because this is also meant, again, as a POC quick start.
Is the Terraform basically the API for the people managing this infrastructure to do some kind of infrastructure as code, but to manage Prosimo?
Correct.
Okay.
Yeah.
And then the repository you have here, is that just kind of a skeleton that you typically, when someone knits a new project, you get these actions basically baked into that repository, ready to roll? All
of it's baked in, yeah.
And then you support obviously more than just GitHub, I assume.
So good question. So yes, where's GitLab, where's Azure DevOps, where are these other things? That's in the backlog, right? So yeah, those are all things that will be coming. Shouldn't be too hard because again, it's really mostly at that point around building the pipelines in those particular platforms.
Oh, that's
the code's all portable.
As you know, coming from an Azure DevOps.
Yeah, well, I mean, the demo we did was ADO. I remember 2 years ago, and I'm like, maybe next time I'll do GitHub, and now here we are doing GitHub. GitHub could not have done this a couple years ago, though. So they've made a lot of advancements in especially actions and other things.
But a lot of the magic sauce is getting it to work across these various pipelines because everyone got their idiosyncrasies and and then you're dealing with all the bugs in their tooling and then you're basically doing it long form.
Yeah, that is the hard part, is getting the stuff consistent across everything and then also making sure that you're catching as many errors as you can. Now, obviously, there's going to be things that are going to pop up. We'll work to address them as quick as possible. But that's, just in the time, I mean, this is months of work, right, that we've done to do this, to make something very simple is hard, right? Because you have to test for all these edge cases that happen, and you won't catch them all, but over time you will.
Well, in fact, deprovisioning is the more brutal of this stuff because deprovisioning takes longer than expected, and like an EI will not shut off in time, and then
and then maybe something happened outside of Terraform, right? Which then that can cause it to fail, right? So it's trying to delete, but it can't because there's a peering connection that was established externally, and it just hangs, right? So
especially EKS is one of the most brutal. I built a whole gnarly framework to be able to deploy and undeploy EKS with Terraform, and it inevitably tear down breaks like 5 out of 10 times because it was just AWS was quietly, we call it eventual inconsistency.
So is the state for your Terraform being stored inside the control plane?
No, so it is being so we have a pipeline as part of this template that you can pick either AWS, Azure, GCP, or Terraform Cloud.
Okay.
And then you run that pipeline. That's kind of the first step of when you clone this, is to say, okay, I've got to configure this one variable that gives me the ability to trigger this pipeline run. That will build the correct backend based on customer preference. We didn't want to force them to do a certain one because not everyone uses every cloud.
Do you have any experience with the Jenkins pipelines?
I don't, but people at Prosimo do. We use Jenkins internally quite a bit, so I'd probably, we'll probably be leveraging them to help, build some of this stuff out in Jenkins as well.
Yeah, so for stuff like obviously Argo, Jenkins, the usual players and Circle.
Circle CI, exactly. There's like so many platforms. We'll try to get to as many as we can, but I mean, there's a never-ending list, right?
How do you manage drift when you've got config drift? So you've got an optimization. We've done regional changes, but ultimately, if your deploy script is dependent, if you were to tear down and stand back up again, it would not pull in the optimizations.
Yeah, so that's all part of some of the unit testing and other things that we're actively working on building, is doing drift detection, doing config drift. I mean, the latest version of Terraform has some lightweight kind of drift stuff. We're kind of doing our own thing though. And then we're,
don't depend on.
Yeah, it's not deep enough really to in its current state. And then we're also working on doing, so what you're seeing here too is we build this build matrix, and based on what's configured in our file of, you're saying here's Azure, here's AWS. If I add a GCP, it would do GCP. But we're adding another step in there as well, where we're saying, okay, if just this file changed, if I just went in and edited this one thing, don't rerun the Azure pipeline too, because you didn't change anything in Azure, which is happening today, right? It's still doing the plan. It doesn't do anything because nothing has changed, but we're trying to, again, minimize that as well. So here we go. The AWS one is done. Azure is still going. GitHub builds by the minute, and I've noticed that the Azure stuff does take a bit longer. So maybe a little double dip on spin there if you're using Azure and GitHub together. So this is the platform. I'm going to click here. You're going to see these networks that are now onboarding, right? We're going to see applications onboarding. These are these WordPress VMs. We will eventually see the Azure stuff come in as soon as it finishes.
When you were looking at the dashboard in the previous demo, you were onboarding one through the wizard, like clicky, clicky, clicky. Like, how does that interact then with the Terraform bits?
So if it's already onboarded, right, and I tried to onboard it with Terraform, it's going to give you your standard Terraform error that I can't do anything with this because I see it's the same name or whatever, right, and it's not under my control. So that's probably something we could look to add to the pipeline and say, okay, if I see something out there, maybe prompt for, do you want to import this, right? So Terraform import the state, and then kind of bring it under control. Something we haven't done yet, but we'll put it in the backlog along with everything else.
Is this Windows based?
So this GitHub runner is Linux, actually. So it's Ubuntu. Yeah. But so with the GitHub runners, you can choose the shell, and with PowerShell core now, it runs in Linux. So there's a mix and match that you'll see in here. So the unit tests are being done in Pester, which is PowerShell, but it's still running on Ubuntu Linux. So the other thing, we've been asked about agent a couple times. I'll actually download our agent just so you can see what that looks like. And I would need this anyway if I was trying to access the Windows systems that we're spinning up in Azure, because RDP, obviously, I would need an agent for a TCP.
How do you manage endpoint agent lifecycle for if you've got changes on the back end? Do you do continuous health checks on the agents and look for lifecycle management of pushing new agents?
Yeah, I don't know if everyone heard that, but
yeah,
Manny said absolutely yes.
Yeah.
All right, so there's agent, obviously works on Mac and Windows. I think we've been thinking about maybe, should we do Android? Should we do iOS? It's been asked, so I think it's still up in the air. If
Linux desktop?
No, Linux, that one hasn't been asked actually. So, but again, if there's customer demand, it'll happen, right? So I'm just going to sign in here. So this is the authentication process. Again, this is tied into.
So does the agent become a local gateway? Is that what you're deploying there? I'm trying to understand where the agent fits in this framework, because you have the edge gateways sitting in the clouds. You've got agents sitting on the end user desktops.
This is for user to app, right? So as a platform, we do not just network to network and not just app to app, but we do user to app. So again, thinking about like remote access, I've got users that are going home, traveling, whatever. How do I get them TCP level access to, again, some legacy thing that doesn't work with a web protocol? That's where the agent comes into play.
So somebody that asked about advanced device posture check, hey, they could access my critical cloud apps only if they come from approved devices, they have firewall turned on, all these things. That's where agent comes. Two use cases. One is kind of developer access, TCP-based access to applications, as well as device posture.
Yeah.
And is it a open generic package that is then tied to the organization through authentication? Effectively, you have one standard agent that you download, you install from anywhere. So in theory, you put in Brew or Chocolatey or whatever deployment methodology you want to look at, apt, and then the actual linking for that agent to whatever enterprise or network is done through authentication.
That is correct. That is through authentication. We do all of the backend plumbing to kind of tie this back into a identity provider like Okta, Azure Active Directory. All this happens in the background.
Okay.
JMF integration, he said, is there also for managing lifecycle. So, okay, so I actually just went in really quickly here, and so we've got these WordPress apps. So we have apps and networks, really, is how we kind of break things down. The apps can be for app-to-app communication. They can also be for user-to-app. I'm kind of showing user-to-app. But these little WordPress VMs that we've spun up, right? So I'm being prompted with now identity to access this thing. There's no public endpoint on those. It's just an IP address. We have the option as well when we onboard an application, and this is great for, again, proof of concept. I can take an existing app that is in use in the enterprise, and rather than saying, hey, change your DNS, point to me for this proof of concept, which would never happen, we can host a DNS entry and say, okay, we can onboard any application that's already running. We'll just host a new DNS entry for it, and then you direct a subset of, your internal users to hit that, where you can test non-disruptively. That's what we're doing here. You'll see this long name, right? access.fullstacktransit.prosimoedge.io, right? So hosted DNS, we created an SSL cert for this. If you notice too, so no FQDN on this app, but I'm accessing it through FQDN. When I onboard this application, we also do a rewrite. That's just part of it, right? So I don't have to deal with URL rewrite, any of that stuff, and off I go, and now I'm connecting to this thing. So if I go look at our insights view, what I should see is me accessing this thing, and I'm seeing me coming from California here, right? So it's even got the city correct, and going all the way to EU West 1, so 164 milliseconds until I get to the, where that application is running, because EU West 1 is in Ireland. And now I'm going to take the option to go back into my little workflow here. I'll go ahead and, I could approve this pull request. I could also continue to make changes. I'll go ahead and let's just make a change, actually. So this is one of the things that I had struggled with also, when I'm trying to figure out infrastructure as code and getting started in this DevOps journey is, how do I know what to type, right? Like, how do I know what field to use when and where? I just don't know. I can copy and paste all day long and it works, but as soon as I get outside of that workflow now, it's a problem for me. So what we've also done is we've authored some VS Code snippets. So with GitHub, you can change the URL from com to dev. It will open up VS Code in the browser. These are packaged as part of the repo. So when you clone it and bring it into your environment, you will, get all of these snippets as well. But under examples, AWS, POC, here's my main.tf, and it's not pretty formatting. I could install an extension to give me nice colors and everything as well. But looking at what we're doing here, right? We have module WordPress 0, module WordPress 1. And I'm seeing here performance is cost savings, right? So, well, what are my other options besides cost savings? I don't really know. Well, this is the nice thing, right? I don't have to know. I can actually just start typing Prosimo, and I'm going to get some of these snippets. I can actually type performance here, and then here I've got options for performance. And just like this, I can make that change, right? So I can make the change here. I can put it in the branch that's currently open. It's going to give me a warning that I have to reopen this editor. You can also, again, if you had VS Code, you could obviously use it on your your local workstation. This flow works the exact same way. Snippets work the exact same way. But again, the idea here is that maybe an infrastructure person doesn't have Git installed on their machine and they don't want to configure it, and they don't have VS Code. They've never used it, right? So simplifying it to where they don't have to go anywhere outside of what's available in the web UI.
I'll claim there's a culture issue if they don't have those tools installed.
I mean, everyone should use VS Code. It's pretty
text
awesome.
over here. Sublime text for the win, baby.
Sublime.
That's how we roll. Interesting. So you talk about sort of many ways to skin the infrastructure as code feline. The idea of you've done everything in line versus modules, which is again tabs versus spaces. I'm with you. I'm an inline cat myself. Because it's easier to see all in one spot. As we get into more complex workflows, customer dependent, I suppose. Obviously, you can choose how you choose to deploy, and also just the parameters. You're adjusting parameters. Some parameters through Terraform, unfortunately, are not smart enough to detect that you shouldn't just respawn the actual core. And I've had this issue before where Terraform gets a little too angry and it will say, hey, this resource is different enough. I'm just going to destroy the original one and respawn it with parameters.
Yeah, which for the POC build here, we had that problem with changing minor things like a security group in AWS, right? You have to be very careful that you use the right kind of ID. Otherwise it says, oh, that changed. I have to blow away your EC2 instance and recreate it. And it's like, well, nothing changed in the EC2 instance. So we're very mindful of that. And then we haven't had to use it yet, but if we did, we would use like the lifecycle management, to avoid those kind of noisy changes that aren't really changes. We, again, in the use of our provider, not been an issue.
Right.
But yes, I mean, we'll keep an eye out for that because it absolutely can happen.
Yeah, well, let me say the Prosimo parameters at least are separated from, they shouldn't trigger that kind of change. But when you get into, like I said, security groups and networking, where it's a Terraform / cloud problem, not a Prosimo problem.
Right.
Solving it.
And there are some things on our side though that will trigger something like that, right? So changing an IDP provider, right? So we support multiple IDPs in the platform. We've got a primary IDP and the partner IDPs. Those partner IDPs can be, you can have many of them, and you can specify which apps and everything are tied to those IDPs. But if I had onboarded an application and said, your IDP is Azure AD, and then I want to change it to Okta, that would require us through Terraform to say, okay, I have to offboard the app, re-onboard it with this new identity provider. But we are always looking to say, can we do that without that process? Is there a way to do it? Sometimes there is, sometimes there isn't. But
the best thing
something like that change you just made applies to the agent running on the desktop, or applies to the gateway that's running close to that? The
gateway, yeah. So it's actually not even the gateway. Well, I'll show you actually. So good question. So the task view here, what's going to happen? And I don't think it's made it to this step yet, but we're going to get a new item that's going to show up here. And actually I can just show you another one. You're seeing the agent logged in. So that's a discovery. Here we go, onboarding a network, right? So when we make the Terraform call to onboard the network, that's hitting, our SaaS control plane, which is then talking to all the other edges. And that's the step that you're seeing down here. Anytime we do this change, network config, all the edges that I have deployed in my environment, which are, those 4, we're pushing that config down to those edges. So that change I just made to say, I want to take this app and now instead of cost optimize, make it performance enhanced. It takes the change, validates it, and then pushes it to every edge so that every edge in the environment is aware that that app is now performance optimized. So all the edges share kind of the state information that we push from that SaaS control plane. So because of this, we always have to say approve and deploy. This last change should go pretty quickly. Oh, there was a problem with one of the gates, it said.
Welcome to Terraform Hill.
Yeah, I think this is a GitHub.
I noticed
thing.
you had to make the change in 2 different places.
I just made it in one place. The code change from performance enhanced.
Yeah,
You know what? I edited 2 different files.
you did edit 2 different.
I edited 2 different files. So yeah, I have a main.tf here, which is all this gobbledygook, right? And then I had the Terraform TF vars. I could move that performance enhanced setting into the TF vars, which we probably will do, because again, we want to try to keep it simple and abstract and say, you don't need to go in and edit this giant deployment file, just change your variables here and then let it go. I could very easily in here say performance equals cost optimized, and then we'll change it from there. I kind of just wanted to show the VS Code thing that we're doing, right? It would work here as well, but yeah, you're right. It was two different files.
So you guys effectively spawn a set of a duplicate of this repository every time a customer onboards effectively, where you kind of go through, create the code.
They can do it if they want. It's there for them to, because not everyone follows, an infrastructure as code workflow. They should, but they don't all do it. So it's up to the customer. Yeah.
Gotcha.
Just to wrap up, we want to talk about, we talked about the basics of the architecture, the components. We showed a CI/CD demo, dashboard demo. There was a question on, hey, what type of customers are using this? Who is the buying center? Like we mentioned earlier, the 3 buying centers, 3 core use cases. The first one being the networking team. This is one of the largest manufacturers in Europe. This was bought by the networking team primarily for a network transit. The use case was, if you look at the left, there are multiple regions in Azure, on the right, multiple regions in AWS. They use multiple different colo providers to get express routes and direct connect, Equinix, Megaport, and so on. For them, handling all of these at the network layer. How do I build network connectivity between all these thousands of VPCs and VNets in that case, and build routing policies and then segmentation policies? They want to make sure that there is a single governance dashboard. They could maintain all of those things. That's the primary use case. Networking team, that's our primary focus as well. The second one is many of us would be aware of. We would be using their products day in, day out. It's a consumer goods company, global consumer goods company based out of the US. It's a DevOps team. Essentially, there was zero networking. They don't even use a transit gateway or a VLAN. Anything IP, they don't touch because of the number of partners their applications touch. They work with thousands and thousands of partners. Everything has to happen at the application layer. They said, hey, these are my applications. They call them isolated VNets in Azure. Each application is running an isolated VNet. Nothing is connected back to the network. In this case, they have the source application, target application. Everything happens through private link endpoint. They wanted Prosimo to orchestrate everything at FQDN layer. So apps could seamlessly talk to each other. You're not plumbing tunnels, plumbing routes. Rather, everything happens at the application layer. This is the app-to-app use case, where it's the cloud platform team, DevOps team is the buying center.
If you look at on the right side of the source app, it's all being using the same IPs. So all that overlapping IP address problem that we hear, it's all being kind of abstracted away with using the private links. So using the private endpoints, you can use any number of duplicate IP addresses in there.
Another reason why they didn't want to touch this at the network layer, because when you work with partners, you can't mandate what IP address they have to use, right? They all could be using the same IP. Because we abstract this through the FQDN layer, we actually become a proxy. The session always terminates on the Prosimo gateway. We initiate another session, so they don't have to worry about, oh, the source app and target app, they have the same IP address. You don't have to worry about that part. That's the second use case. The third is we saw a lot of demo today around users securely accessing cloud applications. There's a financial software company based here in Silicon Valley. They are primarily using this for user to app access. That's another use case. Sometimes this initiative is owned by the corporate security team. They want to make sure that all of the access coming to the cloud are built with cloud native principles, all the zero trust principles, and so on. And if you want to hear directly from them, it's say Prosimo claiming all these case studies are great, perfect, but we actually ran an event called Cloud Networking Summit in the spring, where all these customers we just talked about, they actually presented on, hey, what exactly they did with Prosimo platform. I have put in a link to those who are watching this remotely or in the room. This is our Cloud Networking Summit 2022, where our customers, prospects, whoever is using the platform, either using the GitOps flow or using the dashboard or whatever the 3 use cases, you could go listen to them directly as well.